In this video, I'm going to show you how to solve absolute value inequalities. So inequalities that involve absolute values. Inequalities. So for example, absolute value of 3x plus 4 is greater than or equal to 7. First of all, if we have a greater symbol right here, we're always looking at the side with the variable, and so we always read that side. So the alligator mouth, or the open side of the inequality, is pointed at that variable, so it's a greater than symbol. And if we have a greater, or you could really think of it as a greater statement, an or statement. An or statement. And if you remember, an or statement is talking about values that are on the outside. It's less than or it's greater than. And we'll see that in a second. So we solve absolute value inequalities the same way we would solve absolute value equations. So this is 3x plus 4 is greater than or equal to 7, or it's 3x plus 4 is less than or equal to negative 7. And the way you can remember how to set this up is the one with the negative value on the other side is we're going to be talking about less than, so we're going to be talking about way more less than negative 7. The negative always has the less than, and the positive value always has the greater than. We're talking about greater than 7 or bigger than 7. So solve it the same way we would any other one. Subtract 4 from both sides. So we get 3 and then divide by 3. So x is greater than or equal to 1. And this side over here is going to be subtract 4 from both sides, and 3x is less than or equal to negative 11, and divide by 3. So we get x is less than or equal to negative 11 over 3. Or we could say x is less than or equal to negative 3 2/3. That might help us graph it a little better. So it's either x is greater than 1 or it's less than negative 2/3. And we always got to graph when we solve inequalities. This time I'm going to graph it on a number line. Here's 0, here's 1. So it's going to be, if you remember, a closed circle because it's the or equal sign at 1. We're talking about values greater than 1. So we're talking about values in that direction. And if we go the other way, that's negative 1, negative 2, negative 3, negative 4. So negative 3 2/3 is going to be somewhere right in the middle there. And it's also going to be a closed circle because it's an or equals. And it's talking about values that are less than that, or more less. So that's an or statement. We're talking about values that are separate. They're greater or they're less than. And let me clear this off, and we're going to do another example.
See him. Come in. Where are you going? Really? Never.
here's our other example. The absolute value of negative 2x minus 5 is less than 9. So we're looking at our variable over here, and the tiny side is pointed at the variable. So this is a less than equation, and we could say that it's really a less than equation. So than, and that's an and statement. And that always helps us figure out how to set this up. We're going to set up an and statement, which means that this expression or these values are going to be in between the negative and the positive values on the outside. So negative 9 is less than negative 2x minus 5, which is less than the positive. So we put this in between for and statements. And then solve it the same way we would a regular inequality. Add 5 to all sides. And we get negative 4 is less than negative 2x, which is less than 14. And if you remember in solving inequalities, if we divide or multiply by a negative number to solve for a variable, we gotta flip our signs. So x is going to be in the middle there, and negative 4 divided by negative 2 is positive 2, and 14 divided by negative 2 is negative 7. And you can leave it like this, or you can rewrite it so that the negative is on the left side, but when you do that, make sure that your inequalities are all pointed in the right direction. So negative 7, the tiny side was pointed at negative 7, x was in the middle, and the bigger side was pointed at the positive. So both of these are the same. And if we graph that on a number line, here's 0, here's 1, 2, and 1, 2, 3, 4, 5, 6, negative 7's about there. Remember, we're using open circles because they don't have the or equal line underneath the inequalities, and an open circle at positive 2. And I want values that are less than positive 2, so point at that direction. But I also want values that are greater than negative 7, so point at that direction. So this is what an and statement looks like. It's got things shaded in between two of our outside limits or constraints there. Alright, so that is solving absolute value inequalities in a couple examples. One greater example and one less than example.